We mentioned before that in statistics, we generally deal with data that comes from a sample, some smaller group that represents a larger population. And achieving a random representative sample is one of the most important aspects of statistics. A sample, that smaller group that we study to help us understand the larger group, should have the same characteristics as the population it represents. Put an S on the end of there. So our sample should reflect the larger population. We're obviously looking at fewer people, fewer objects, but there should be similar characteristics between the two. The most basic kind of sampling is referred to as a simple random sample. This is where every individual, every item that we're trying to study is we randomly select from that group, and every individual, every item has an equally likely chance of being chosen. So if we wanted to understand something about all residents of Illinois, we would have to just randomly pluck people from throughout the state, but also keeping in mind this idea that the people we pluck should have similar characteristics to the population as a whole, in terms of ethnicity, income level, all sorts of characteristics and factors. We can also use what's referred to as stratified sampling. In stratified sampling, we divide the population into groups called strata and then take a proportionate number from each stratum. We're going to think of this in terms of a business. So in a business, we would have folks probably already naturally divided into different areas: marketing, sales, HR, public relations. And so on, whatever groups we could come up with. So we would identify those different groups, and if we were dealing with a different population, we would have some other groups we'd establish. And then we choose an equal number of random people from each of those groups. So 10 people from marketing, 10 people from sales. What that does is helps us with representation. We know we have folks from marketing, we know we have folks from sales, and so on. But we're still getting a random group of people. We also have what's referred to as cluster sampling. In cluster sampling, we divide the population into clusters or groups and then randomly select some of those clusters. So we'll actually go back to what we were talking about with stratified sampling. In this case, though, rather than choosing the same random number of people from each group, we would randomly pick a certain number of groups. So let's say we randomly select marketing and public relations. Then we would survey or measure whatever variable it is we're interested in from every single person in those two departments. So we're not randomly selecting people, we're randomly selecting the groups, and then surveying or measuring something about every single person or item in those groups. There's systematic sampling, where we randomly select a starting point and take every nth piece of data from a listing of the population. So that would be, if we're still dealing with our workplace example, our business example, we would create a list of all of our employees, maybe say putting them all in alphabetical order or something like that. We would choose a starting point randomly, like say 7, and then choose every 10th person, every 20th person, 50th person, starting with that randomly chosen person. And we would cycle back through our list if we needed to until we hit our representative number that we need, however many people we're interested in sampling. The last general type of sampling is referred to as convenience sampling. And the best thing to say about convenience sampling is that this is bad. This is our worst kind of sampling. It literally is what it sounds like, convenience sampling. You just do whatever is most convenient. All of those things we just described, systematic, cluster, stratified sampling, takes a lot of planning and work, even simple random sample to try to make sure everybody's equally likely to be chosen. In convenience sampling, you would sort of just ask the people around you, whoever's nearby. But that's very unlikely to give you the representative group that you're after. When we engage in sampling, sampling errors will always exist. That's unfortunate but true. So what statisticians do is everything they can to minimize that. Due to the variability of samples, it's likely that any two samples could yield different results. That's one idea we need to keep in mind with random sampling. And we also need to be aware that sampling bias can occur. And that occurs when some members of the population are less likely to be chosen. So if somehow something is failing in our random selection of people, then we start introducing sampling bias. We can also have non-sampling errors that occur. Which would include things like faulty measuring equipment, if we were collecting data on people's weights and our scales just weren't functioning correctly, or if record keeping is not being done carefully and the wrong data values are being recorded. There are just different ways. So there are lots of different ways that errors can occur as we look at these different samples, and we just need to know that statisticians are doing everything they can to minimize those errors so that the results we're basing conclusions off of are hopefully as good as possible.